Hello, I'm ETarte, math teacher. This is a solution video for my triangle and circle math challenge. In that challenge, I presented an equilateral triangle, that is a triangle with all three sides the same length, and inscribed in it is a circle, that is the circle is tangent to the triangle at these 3 points. And I asked the simple question, what is the ratio of the area of the circle to the entire area of the triangle? In other words, the area of the circle is what fraction of the entire triangle's area? Well, to solve this, we could call the radius of the circle r, or we could pick a specific radius. I'm going to just suppose that the radius of the circle is 1 unit. The formula for the area of a circle is pi times the radius squared, that is pi times the radius times the radius. And if the radius is 1, that's pi times 1, which is simply pi. So pi is going to be the numerator of our fraction, that is the area of the circle over the entire area of the triangle. Now for the denominator of our fraction, we need to find the area of the entire triangle. I have drawn this triangle from the center down to this point of tangency. By a fact of geometry, this is a right angle, and we said the radius of the circle is 1. Every angle of an equilateral triangle is 60 degrees. This splits that angle in half, so that's 30 degrees. So we have a 30-60 right triangle. And geometry students learn that the shorter leg is multiplied by 2 to get the hypotenuse. So this is 2. And then using the Pythagorean equation, they learn that the longer leg is the shorter leg times the square root of 3. So this length is the square root of 3. If you don't know that, you can find it using, as I say, the Pythagorean equation, a squared plus b squared equals c squared. Now the area of a triangle is the base times the height divided by 2. So to help me find the area of the entire triangle, I'm finding the area of this one, which is base, root 3, times height, 1, divided by 2, which is root 3 divided by 2. That's the area of this triangle. Well, the entire triangle is made up of 6 triangles like this. 1, 2, 3, 4, 5, 6. They're all congruent to each other, and so I multiply the area of that one, which is root 3 over 2, times 6, which gives me the entire area of the triangle, 3 times the square root of 3. And so the ratio of the area of the circle to the entire area of the triangle is pi over 3 times the square root of 3. And that is the exact answer, the best answer to my math challenge. I put that into my calculator to get an approximation, and my calculator gives 0.60459978881. That tells me that the area of the circle is barely more than 6/10 of the area of the entire triangle, barely more than 3/5 of the area of the entire triangle. So that's my solution to my triangle and circle math challenge. Thank you for watching and listening.